let's get started. So in this section, before writing any code, let's fix the Cortex-Debug part, then we'll do the Ceedling part, okay? So we need to create a launch.json file. Just click anything here, and it's actually created in .vs code here, so we have the launch there. So if you don't have it, you can create it there if you find any issues with making it. All right, let's get this over and done with fast. Just copy this part here, and yeah, that's what you need. All right, so make sure everything is done pretty good. Okay, so you have the name, workspace. This is important. You're executable, so to specify the correct location if you have something different. Right, it's in build. The dot just means it's the current working directory, and then you go into build, and then you'll find your final.dll. Launch type, we got the Cortex-Debug. Server type, OpenOCD. We covered that already. The interface, we're using serial wire debug. And this is the device I'm using. You have configuration files. We have interface and target. Right, let's sort these guys out, and we'll get to SVD and where to find it. So OpenOCD. All right, OpenOCD. All right, so I'm assuming you already installed OpenOCD. Not installed, but you have it downloaded, and inside here you have your application itself, the executable, and obviously you added this to your environment variable. I have it in downloads. You should probably not do that. You can use it, put it in your C drive and just do that. All right, so you should probably do that now. We're going to share OpenOCD scripts, and first of all, I want you to take note that we have three things over here. We have target, interface, and board. Now let's sort out the interface first. So we are using ST-Link. In this part, we have v2-1. I'm just going to open this up, and it's actually saying that it's deprecated. So we should just use this essentially. Right, so I'm just gonna backspace. You can use that, right? All right, and next, let's assume you have a board. Sorry, that was fast. Let's assume you have the board, and we're not talking about the MCU. So let's assume you have a board there's a variety of boards here. You have a Nucleo board, maybe. You have a Discovery. Just select the type you're using. I'm assuming you're just using one of these boards. You have L0 Discovery here as well. Yeah, all right. So these are the boards. Just select your type. But in my case, and then you should put board here as well, and then the name as well. Okay. But in my case, I'm using the target because I have my custom board that I made. So I'm using STM32 L0 right here, right? You could have another variant, just need to replace that name here, okay? For target, okay? Whatever it may be. All right, so now we have the SVD file. So it's showing that I have it here in the current working directory. You probably don't need to put it there, but you know, since I have it there, I'm just gonna keep it there, okay? Let me just go get that file. Test copy. All right, just gonna copy that over, and I'm gonna paste it over here. Opa, never mind. Just gonna drop it like that. All right, I have my SVD file. That's fine. Okay, where to find your SVD file? Okay, let's go here. You can find it right here in tinygo-org. So you can find your SVD file here for STM32. Okay, I found mine here, and this is the one I'm using. All right, so just find your corresponding target for your specific custom board, you know. or if you have a nuclear discovery board, just find your specific SVD file here, right? I think he did everything here. I'm not quite sure, but it looks like everything is here. F, G, L, H, yeah, and W is here as well if you're using that board. All right. I think that kind of covers this part. You can now go to your run and debug part. It should show you this. If everything was set up perfectly, it should show you that. All right. And that's that part. All right. Now let's get to Ceedling. If you double click there, make sure your terminal window is open. You can see that failed to find the project.yaml file. So if you go here, you can kind of see that our file is in source, right? It's in source, current working directory, and then in source. So we need to fix that. So it says, please check the Ceedling Explorer.project path option. So we go to File, Preferences, Settings. We go to Workspace, because this is our current workspace. And then we just type project path, right? Okay, here we have it, Ceedling project directory. Now we just have dot here, right? But it's looking for the project.yaml file. So it's stored in source. Okay, here, it's stored in source. So whatever your name is, you just place it there. But I have it as source. So that's done, right? Make sure it's in your workspace. But I think user space, it's just like in general, right? So whatever. Let's go back. Let's refresh this guy. Oh, we have another problem. All right. So it's saying it requires this plugin. Let's copy this because it's not enabled, and then go to your YAML file. Scroll down to the bottom, okay, and then just add it there. All right. Let's go back. Refresh. Okay. Let's just wait. All right. It seems that the issues are gone. It seems everything is fine. There's no issues. Okay, pretty cool, right? So that is done. Everything else seems to be fine. Okay, let's see if we can start the project. Right? I think I covered everything we required. So let's get back to the next lecture. We will be creating a driver. We already have our main file, okay? Because we just want to test out a few things, I'm just going to create a ticks variable. Because we need to create a delay and everything, so I'm just going to create a volatile uint 32 ticks variable equals to 0u, right? As soon as the sysdig handler is called, it just implements, okay? Because we did the sysdig config here, so it's going to jump to the sysdig handler every millisecond, okay? So we're just incrementing the variable. All right, so yeah, that's just to make sure everything is fine. And just to make sure everything is in order, just make all. Okay, let's make sure everything is compiling. If there are no issues. All right. Okay, make clean. We are good to go. So what are we going to do now? Let's start off with Ceedling. So our Ceedling project is in source. So we're going to just change the source. Okay. What we are now going to do is do Ceedling module create. What are we doing first? GPIOs, right? So we're going to create the GPIO driver. Just keep it as GPIO. Let's create that. All right. We have 3 files created. In source, we have GPIO.c, the header file as well, and the test file. All right, we have these guys. Okay. Let's just open them up. As you can see, it's done good for us. This is fine as well. And then inside the test, we go here as well. I'm just going to remove this test section So that's the nice thing about Ceedling. You just, it does this for you already. You don't need to do all of this. It's quick and easy. So we can't find Unity. Remember that I said I actually stored Unity on my C drive. So we're gonna have to add that. We're getting this error. Please update your include path. Okay, no problem. Let's just go to look at our settings. All right. Let's go to preferences, settings, remember workspace, include path. Okay, scroll down. Okay, what are we looking for? C_CPP, include path. We'll use include path. Okay, add item C, Unity, source, and then this double star just means include everything in there. Okay, that solves the issue. We can also verify it in settings.json. Okay, everything seems fine. Unity sorted out. F12. Okay, it's sorted out. All right, this is what we have here. Because I opened up Unity header file, it's now placing in that file for the association. All right, so don't be too stressed about this part here. Okay, so this is actually all we added here. Okay, so now let's see if we can start using everything inside Unity. We have test. All right, we have it up. The assertions, we got all of them. This is all the assertions you can have for Unity. All right, so just use test assertion. These guys at the bottom, you don't need to use them. Okay, just care about these guys at the top. It starts with test. That's what you can use. Okay, now obviously we need to write some sort of test. But before we start doing that, let's actually go to the sidebar. Okay, let's refresh this. It's taking some time. All right, we have the GPIO. What do we have inside of that? The need to implement. Okay, so if you create other drivers here like UART, ADC, it's all going to show up here, right? And then you can just run run test. So let's do a quick example of that. This is what you can do here, right? Just to run your test, and this is kind of the output you will be receiving. It says test passed, and you did one test. Okay, so let's do here test assert bit high. Okay, so the bit itself, let's use 1 and the actual is 1. Now it should pass. Let's say it should fail. Let's make that 0. This guy should fail. 1 test, 1 failure. Okay, and then you can obviously click on it and it tells you what it was expecting. So in our case, and here you can also see some things. All right, let's say you don't want to use the sidebar for whatever reason. Okay, you can just write Ceedling test. You can write all. It's going to test all the drivers that you wrote here. Basically, what you're clicking, like when you click this one, all tests. This is actually the command that does it for you, right? But let's say you want to do just the GPIO. Then you just type GPIO or UART or ADC and so on. So let's do the GPIO. Basically, it runs and then it just shows you all of this. Exactly the same kind of thing. Let's just run this again. Some time. Yeah, it's going to tell you what the problem was, right? Okay, so that's kind of a little intro to what we're kind of doing. And in the next lecture, we will actually start implementing this driver. Stay tuned and see you in the next video.